Hello, welcome to my channel. In today's video we'll talk about internal loading in terms of forces and moment that occur in a structure or solid body due to external forces. As we are aware, a structure is a solid body supported at one end or both ends. As we have discussed in our previous video. At that time we talked about support, free body diagram, and the equilibrium equations. Well, so now we have two types of loading, external and internal loading. The external loading are forces that is intentionally applied to the structure, either longitudinal or axial loading or lateral loading. However, the internal loading is the response of structure due to the external loading. So how to calculate it? How to calculate the internal loading in terms of forces and moment that occur at certain points in a structure or solid body. We'll discuss this material in this video. We will use the equilibrium equation, and of course you already master how to draw free body diagram, right? Okay, now let's start. Don't miss it.
Advil after that. Look at that. That's what happens to golf.
Don't miss it. Okay, let's get started. Talk about internal forces. Let's consider the beam right here. Is actually cantilever beam, fixed support at A, and then let's see, there are two external loading P1 and P2 on the beam, and let's neglect the gravity weight of the beam right here. So the question is, we have to know the internal forces that act in the beam. Say at B, right here. Yeah, we may consider in other location, say C, okay, or maybe here at D, wherever we can calculate and find the internal loading acting there, moment or forces. So first of all, let's draw a free body diagram as in our previous video. So because of the fixed support here, we have AY, we have AX, of course, and there is a moment also at A, the bending moment. The thing is, the bending moment due to P1 work something like that, because this one is fixed. Okay. Of course, this one we have vertical direction and another axial direction. Also create in y direction, say P2y, we will create also moment. So this moment is supposed to be countered by another moment at an There's Newton law, the third Newton law said. Then how about at point C? At point C, we have to expose the internal loading condition in here to become the external loading. How to do that? We apply what we call method of section. So it's shown in here. So if we cut, so at A, we have normal force NB and shear force VB right here. And of course, the bending moment MB. So in order to have a balance, equilibrium condition, so all we have to do is in another section, because we have two segments, right? So in another segment at B, we apply normal force, shear force, and moment also, but in opposite direction. Now, I hope you understand, and this is how it works. This is how we introduce a free body diagram and write down what forces and moment acting at the location we are going to now. The point is here, the internal loading now clearly exposed to the external load, VB, NB, and NB. Okay, let's take a look at if the loading condition acting in three-dimensional state of stress coefficient axis, so there are two kinds of moment acting here. In Z direction, of course, is bending. So now the car is bending moment, and in X direction also bending moment. But in the Y direction, it's very clear that it's also moment, but it's twisting moment or torsional moment. So torsional moment will create shear force like this, shear stress like this. So the normal stress in Y direction is NY, and of course we have shear force Vz in Z direction, and another shear force Vx in X direction. Now let's check this example. So in this example, we have to determine the normal force, shear force, and moment at point C. So shear force, normal force, and moment are actually the internal loading. So we cannot calculate, we cannot, we don't know what is the internal loading in the beam until you make it, visible. To make it visible, you expose the internal loading into external loading by cut it at any location, say at C. And then write down the free body diagram as we have learned before. Because A is pin, pin support, we have AY and we have AY and we have AX. So no moment here because not fixed support. And this one is a roller, so only BY. This is the length of the beam. And external concentrated external loading are 10 kilonewton and 15 kilonewton. So all we have to do is now we regenerate the equilibrium equation. First of all, sigma summing of forces in x direction, sigma fx equal to 0. And then from here, it's very easy to find that ax equal to 0 because there is no axial force acting at the beam. And then sigma fy equal to 0. So let's see what we have here. We have AY and BY plus because to the upper direction, and then 10 and 15 minus equal to 0. So AY plus BY equal to 25. Let's note this is equation 1. And then let's take a moment at any location at A or at B, results will be the same. So I would like to take at A, sigma MA equal to 0. So what we have here, if MA equal to 0, okay. Due to 10 kilonewton is here fixed, right? So we have this moment, and then from here we have this moment right here, and then this moment right there. So counterclockwise direction is plus and clockwise is negative. So look, so minus 10, this is this way. So clockwise, so minus 10, and then the length is 1.5, and then minus 15 multiplied by this length, so 4.5, and then 6 by equal to 0. Yeah, 6, right? 6 by. So the leverage is 6, and then we calculate that. We found that by is 13.75 kilonewton. And then substitute this by in this equation right here. What do we have? AY plus 13.75 equal to 25. Then we got AY 11.25. And then at point C, let's see again. At point C, okay, right here, what do we have? Sigma fx equal to 0, of course, and C equal to 0. And then how about Vz? See, we have Vz sigma Fy equal to 0. We have this one is 17, no, 11.5, 25, this one. And then minus 10, because this is the segment that we talk about, minus VC, the shear force at this location, is equal to 0, then VC is equal to 1.25 kilonewtons. How about the MC? To conclude that first of all, we have to understand, to review, to go through again how to draw a free body diagram and then generate a equilibrium equation and solve the equation using the support condition of the grid. Okay, that's all. Thank you very much.